To topic number 6, we're going to be calculating distance. And now, remember that when we learned in the last unit that distance, we know this word, the length, okay? So distance is actually just finding the length between 2 points. And we actually kind of have already been doing that. If I have, let's say, this number line, right? And I'm saying this is 0, 1, 2, which makes this -1, -2. And I plot 2 points on here. Let's say point A and point B. Right? We actually know this distance. We use it to help us find the midpoint on a graph. This distance is 1, 2, 3. So what that helps me figure out is that the measure of the segment AB, that measure is actually going to be 3. Okay? So we've kind of already found the lengths of segments. But now, I would think if you remember, your teacher probably said that you can't actually count the length of a segment when it is slanted. Horizontal and vertical we can count, but when it's slanted we can't, and that's what we're going to focus on today, okay? So let's look at example 1, and we're going to follow these steps on the left. So if you need to take a second to pause the video to write down these steps, please do so now. So step 1 is to plot the points. L is -5, -2, so -5, -2, that's right here. That's going to be L. And then K is -2, -8. That's down here, that's K. And we get this segment. Right? Now notice that segment is slanted, it's diagonal. It's not going up, straight up and down or left and right. So that we've done step 1. Step 2, we're going to make a triangle. So I'm actually going to take my 2 endpoints and connect them by counting vertically and horizontally. And if I connect these 2 at this point, that makes a right angle, okay? So now notice I have a right triangle, right? I'm going to add a little mini step in here. I'm going to say find the lengths of the legs, okay? Because we actually can find the lengths of these orange lines, right? I know that this orange line is 1, 2, 3. That is 3 units long. And I know that this orange is 1, 2, 3, 4, 5, 6. That is 6 units long. And I'm looking for this length here, X. Okay? Well, now notice, look at this picture here. This is a right triangle. I know the legs, and I'm looking for the hypotenuse. So step 3 is to use the Pythagorean theorem to help us find the distance. Okay? So we know that the C is across from the hypotenuse, which we have here. That's X, so X squared equals A and B, doesn't matter, 6 and 3 there. So let's call A 6, 6 squared plus 3 squared. And what does that get us? 6 squared is, now we should be good, 36 plus 3 squared is 9. Add 36 and 9 together and you get 45. At this step, right, we take the square root of both sides. That gives us X on the left, and we're left with the square root of 45 on the right. And there is my distance, right? Now the square root of 45, that's kind of a weird number. We can take that number and actually estimate it, okay, by either using the number line process that we learned in class or using a calculator. I'm going to use a calculator, and I'm going to say that the square root of 45 is about 6.708. And that gray line clearly looks like the longest side, right? And so it makes sense that this is the biggest number we got. It's bigger than 3 and it's bigger than 6, okay? But that is our distance, all right? So why don't you pause the video here and see if you can try example 2 on your own, and then we'll check the answer. I'll show you the answer after, okay? So pause the video. So here is the answer to example number 2. What you should have noticed is it's actually the same exact answer as example number 1. So things that could have been different. We should have gotten the square root of 45. We should have been able to plot it. Some of you, though, may have had the triangle that I drew. You may have had a triangle that was, oops, sorry, I just want to change the color, that was going the other way. if this was you, that should still be okay, because this side is still 3 units long, and this side is still 6 units long. So you're going to get the same numbers anyway. So if that was you, that is okay. You did not do it incorrectly. All right. What the other thing I want to talk about is what the answers look like. So right now, this answer is the square root of 45. This is my exact answer. Okay? So if I say, what's the exact distance between F and H, your answer is the square root of 45. Sometimes I could ask you to estimate, right? And that answer, that's an approximate answer. That's what these squiggly lines mean. And approximately this answer, that's our decimal, 6.708. Okay? So this is how I find distance from a graph. Let's look at what happens when you don't have a grid. So when I don't have a coordinate grid, I have 3 options. The first one, get up out of your seat, go ask your teacher, and get graph paper, right? Make a coordinate grid and plot the points and find the distance just like we did on the other page. Okay? We're going to do example 3 like this one, all right? So another option that you can have is to find the distance between your x's and y's and visualize that triangle, all right? And then the third option that you have is to use the distance formula, right? This formula will always get you the distance, the length, d, okay? Let's use method number 2 for this example here. It says calculate the length of the line segment JK, right? If the coordinates of J are negative 4, 11, and K are negative 3, 4. So we're finding the length. Remember, the length is the same thing as saying the distance. Okay? All right, so I actually just want to visualize this. I'm going to draw like a mini X coordinate grid over here, but we're just going to kind of like plot it. I'm not going to make it too exact. So J is negative 4, 11, so that would be if I go left and then up, and J would be somewhere around there. And K would be negative 3, 4, which would be left and then up, but not as far left and not as far up as J, right? So I get this line segment right here, okay? What we would do with the process we learned yesterday would be to draw a earlier in the video, would be to draw a triangle and find the length of this side and the length of that side, right? Well, if you think about it, this length going vertically, that's affecting my y values because my y-axis is going up and down, right? And this length horizontally, that's affecting my x's because the x-axis goes horizontal left to right, okay? So I actually don't need a grid to count this because what I can do is I can just look at my coordinates. One of my coordinates for the x was negative 4, the other coordinate was negative 3. How far away are negative 3 and 4? How far would I have counted? And the answer there is 1, right? I would have gone from negative 3 and counted over 1 to negative 4. So that means this side length there is 1, okay? Then we can do the same thing with the y's. One of my y's is 11, one of y y's is 4. How far apart are 11 and 4? 4, 5, 6, 7, 8, 9, 10, 11. Those are 7 apart. So that means that this distance vertically was 7. Okay? Well, notice, now that I know those distances, those have become the legs of my right triangle, so I can use the Pythagorean theorem. And those distances that I found, I'm still looking for the hypotenuse, right? So the C is still the x, and the distances have become A and B in my formula. So I get x squared equals 1 squared is 1, 7 squared is 49, add 1 and 49 together, and I get the square root of 50. Oh, excuse me. I was one step ahead of myself. Add 1 and 49 together, and I get 50. Then I take the square root of both sides, and I'm left with x equals the square root of 50. This is my exact answer. If I were to estimate that, it would be somewhere around 7.071. So this is approximately 7.071. Okay? Let's look at one more example, okay? What I want you to be thinking about while I do this example is which method do you like better? Do you like visualizing the distance between the x's and y's and using the Pythagorean theorem, like we just did? Or do you like using the distance formula, which we're about to do, okay? So when I use the distance formula, this is the formula here. You would have to be able to remember it or write it on your note card, okay? I'm finding the distance between the point C, negative 3, 4, and D, 1, 6. So as you can see, I labeled x1 and y1, and then x2 and y2, okay? And all we have to do is fill these in. So that means that the distance equals, I have the large square root, and in the parentheses, I'm going to subtract x2 minus x1. So x2 is 1, and x1 is a negative 3. So that's going to be a 1 minus a negative 3 squared. Notice how I put negative 3 in parentheses there. That's very important. I'm going to add that to y2 minus y1. That's what's in the parentheses. So 6 minus 4. And that's going to get squared. Now we just have to keep track and do order of operations. So my distance equals the square root of, we do parentheses first, 1 minus a negative 3, that's going to be addition, okay? So that becomes a 4, and I'm squaring that, okay? Then I do the parentheses here. I'm adding that to, 6 minus 4 is 2, 2 squared, right? Now I can do the exponents. 4 squared gets me 16, 2 squared gets me 4. Then I'm going to add together. 16 plus 4 is 20, and I have the square root of 20. And I'm going to ask myself, is that one of my perfect squares? The answer is no, so there is my exact answer, okay? This example is exactly the same as what we did in the example above, because notice, what's the distance between negative 3 and 1? That distance is 4, and I see the 4 right, the 4 right here, okay? What's the distance between 4 and 6? That distance is 2, and I see the 2 right here, okay? And then you would follow the same steps to simplify. So figure out which one you like to do more, and stick with that one, and continue to practice with it, okay? Good luck on your homework, and we'll see you in class. Bye.